Hello everyone, my name is Wang Fei. Today, I'm very honored to be entrusted by teacher Lian-huan to give a speech on this conference paper. The topic of the paper is Research on Load Feature Extraction Method of Typical Users Based on Deep Learning. I will use the following 4 parts to show the content. Introduction, User Load Feature Extraction Method, Analysis of Results, and concluding remarks. Firstly is the introduction. In order to improve the calculation efficiency and extraction accuracy of typical user load extraction, the research on typical use load extraction methods is carried out in order to realize the typical user load extraction quickly and accurately. As one of the key technologies of load monitoring for typical users, the function of load extraction is to extract and analyze various power consumption characteristics of residents, businesses, and administration by using the load characteristic extracted from load monitoring data. At present, there are many researches on the implementation method of load extraction of typical users, which mainly use 2 kinds of methods: mathematical optimization algorithm and pattern extraction algorithm. When using mathematical optimization algorithm to extract load, most of them use differential evolution algorithm and genetic optimization algorithm. But this method faces many problems due to the complexity of the mathematical model, such as the low efficiency. The commonly used pattern extraction algorithm is supervised learning algorithm. However, these 2 methods have the problem of low accuracy. So, this paper proposes a typical user load feature extraction method based on deep learning. The second part is the user load feature extraction method, including typical user load data clustering, user load classification, and implementation of characteristic extraction of typical user load. Before clustering with k-means algorithm, data processing is needed. In the whole process of data clustering, m-sample data are formed into the sum of squares of cluster center distance with characteristic attribute. In the clustering process, the square of the distance between the cluster centers and the extreme value of the objective function needed to be taken. Here gives the calculation formula for cluster centers, which calculates the distance between the sample data and the feature clustering center. The power consumption characteristic data is obtained by sampling and processed, and sent to the data processing center to measure the power consumption of the users in combination with the total electricity consumption. With the support of deep learning algorithm, complex power consumption feature extraction is carried out to fill in the missing value of user power consumption, smooth noise data, delete of cluster points, and avoid unreliable data output. To solve the problem of low extraction accuracy, a typical user load feature extraction method based on deep learning is proposed. In the deep learning algorithm, the principle of typical user load feature extraction is studied, and the data is cleaned. integrated and pre-processed to avoid noise interference. Through the cluster decision-making power consumption feature points, the information gain of power consumption characteristics is obtained, and the complex power consumption characteristics are extracted to provide better and high-quality services for users. Load extraction problem can be described as following mathematical problems. Assuming that the formula is true, the solution of the following formula is satisfied. Time and temperature have the greatest impact on the power load data. So, in the process of intelligent short-term load forecasting combined with deep learning algorithm, the time and temperature data needed to be integrated, and the power load data of a certain period of time can be predicted through the network. And the training sample selection process as shown in the figure. This article regards each independent user as the basic unit of constructing the feature library, and unlimited categories the classification problems is transformed into a limited category classification problem. The Bayesian classification model is used to classify the load, as shown in the formula. The category with the largest probability is the label of load K, as shown in the formula. The load identification quick optimization model is further established based on the waveform similarity. The collected mixed signal can be estimated by the linear superposition of the current of the N-type electrical equipment. So the current mixed current signal can be expressed as follows. The problem of load identification is transformed into a set of optimal weight coefficients A1, A2 to AN, which makes the load superimposed current most similar to the real current. The optimal weight coefficient at the current moment is determined by the minimum residual method. This paper samples the current and voltage according to a certain frequency to detect the effect and records the voltage and current waveforms in the last 2 seconds in the buffer. The current intensity calculation of each circle current signal can be expressed as follows. If the current and intensity of one circle has sudden change compared with the previous circle, the eta are the thresholds for judging the sudden change of the steady-state current, and it can be considered that a load switching event has occurred. The fundamental phase angle of the steady-state current is determined by the initial phase of the voltage during the measurement. Therefore, it is only necessary to ensure that the steady-state current is measured under the same initial phase angle voltage to meet the current superposition. Deep learning is a method of machine learning based on representation of data. In this paper, the inherent characteristics of those steady-state operations are used for fast clustering. Therefore, the results of those characteristics based on deep learning can be expressed as follows. Since the numerical range of different features is different, normalized each feature according to the following formula to get. According to the duration of each switching, the change degree is judged as fixed or non-fixed operation time load, as shown in the formula. Obtain current and voltage sampling data through data acquisition methods such as smart meters and calculate characteristic values such as overall power and harmonics. The user load feature extraction process is standardized, as shown in the following figure. Through the above process, the number and typical of electrical appliances can be extracted under the condition that the situation of household appliances is unknown, which can solve the data problems for power consumption behavior analysis and smart home appliance applications. The third part is about the analysis of results. In order to verify the practical application effect of typical user load feature extraction methods based on deep learning, comparative experiments are carried out, and the mathematical optimization algorithm is taken as the traditional method. The parameters of experimental equipment are standardized, as shown in the table below. The difference feature extraction method proposed in this paper is used to extract harmonic features, as shown in the figure. It can be seen that the distribution of active and reactive power features of some electrical equipment is relatively concentrated, which is not conducive to the classification and extraction of clustering algorithms. After harmonic features are used to replace the reactive power, the load features are clearly divided into 5 regions, which can be more effectively perform fuzzy clustering extraction. When active and harmonic features are used, the entropy value between clusters is higher than that of the active and reactive features, and it is optimal when the number of clusters is 5, which is consistent with the actual situation. This shows that the differences feature extraction and fuzzy clustering methods used in this paper can efficiently extract node features and can perform fuzzy clustering based on intercluster entropy when the device type is unknown, and improve the accuracy of load extraction. The load identification accuracy of typical users such as residents, commercial and administration, transportation, and industrial is shown in the following table. It can be seen from the table that the correct rate of load identification of this method is higher. In order to further verify the performance of the method in the paper, high-power home appliances are used to detect load characteristics. Based on the analysis of the test results, The details are as follows. According to the analysis of table, the extraction accuracy of typical user load feature extraction methods based on deep learning has been significantly improved compared with the traditional method. Finally, it's the concluding remarks. This paper mainly proposes a typical user load feature extraction method based on deep learning. The k-means algorithm is used to cluster the user load data. The typical user load sample data is selected from the clustering results, and the user load categories are divided, and the typical user load characteristics are extracted according to the classification results combined with the deep learning method. Finally, simulation experiments show that the method in this paper can achieve effective and accurate load extraction. That's all. Thank you for your listening.
Hello, ladies and gentlemen. I'm Wang Fei-feng. I'm honored to have the opportunity to give a speech on this conference paper here, which is named Research on Grid Planning Method of Distribution Network Based on Artificial Intelligence Technology. The content of this paper will be divided into 4 parts, including Introduction, Grid Planning Method of Distribution Network, Analysis of experimental results, and conclusion. First, let me show the introduction to you. As an important part of the entire power grid, the distribution network is mainly responsible for providing continuous and stable power supply to end users, especially with the rapid growth of social power consumption. Traditional distribution network planning methods can no longer meet the large-scale medium voltage distribution network. The distribution network directly faces the end users and is an important infrastructure serving the people's livelihood. The grid power planning based on power demand and regional regulatory planning can improve the work efficiency and service level of distribution network. The second part of the grid planning method of distribution network. The use of artificial intelligence technology in the grid planning of distribution network is to divide the area to be planned into several areas according to the classification of distribution network power supply area. The difference in the nature of the land and the degree of development. The power supply ranges of this area are relatively independent and will not overlap, starting from the terminal demand of the power market, meeting the needs of users as the goal and guide. Turning to bottom-up planning method, adopting the planning concept of low voltage first, high voltage. Refer to the typical load forecasting model carries out differentiated system load forecasting. Through practice and calculation, the following problems exist in the urban distribution network planning schemes. First, when the power grid is in full operation, the short current often occurs in the power system. Second, the variable capacitance cannot meet the supply and demand regularly. Third, the load of distribution lines is too large. Fourth, distribution network construction funds are insufficient. This article mainly uses artificial intelligence technology to determine the scope and content of the plan. Determine the base year, level year, and saturation year of the plan, and propose relevant planning methods and evaluation standards, and then successively carry out planning for the target area. In the above process, the use of artificial intelligence technology for grade division, load forecasting, and distribution network structure is the core of grade planning. The main principles of grade division of planning area are as follows. First, based on the current situation of medium voltage distribution network, the blocks with different land use properties and development depths are classified according to the regional regulatory detailed planning. Second, the size of each grade should be determined according to the power supply capacity of a set of standard wiring. Third, the layout of medium and long-term substations should be planned in combination with artificial intelligence technology, and each grade power point should be determined. The selection of power points should meet the principle of proximity. Fourth, the power supply points in each grade shall be from two different substations, and the power supply lines of the same substation should be from different bus sections. The optimization of the grid planning process of the distribution network is shown in the figure. According to the relevant power supply area division standards, combined with artificial intelligence technology to determine the planning area power supply category, and use the corresponding technical standards for distribution network construction. After grade division, each grade needs to be coded. The first item of grade number is the first letter of local city pinyin. The second item is the first letter of district or country. The third item is the first letter of pinyin of street or development zone. And last item in the sequence number is the sequence number of the grade. Each item is connected by the character 1. In order to avoid problems such as unreasonable distribution of substations, unbalanced load, and so on, a hierarchical structure is established for the grade of distribution network. According to the 3 voltage levels of high, medium, and low, the distribution network is divided into 3 layers, L1, L2, and L3. According to the concept of grade planning, a bottom-up approach is adopted to carry out layered work on the distribution grade, namely the form of L3 to L2 to L1. The specific process is as follows. According to the planning objectives, load forecasting is carried out in the planning area, and the existing distribution network saturation is evaluated. For the purpose of optimal power supply, several power consumption properties are similar and geographical located. The adjacently connected L3 layers grades are combined to initially generate L3 layer grades. According to the combination and division of L2 grade, the required new substation capacity is calculated, and the location of the substation is planned according to the grade structure of the target area. After the L1 network scheme is formed, the L1 grade layout is solidified, and rationality of the combination scheme of L2 grade generation is comprehensively elevated. According to the evaluation results, the L2 grade is modified and adjusted. In the grade load forecasting, according to the different forecasting time and duration in the future, load forecasting can usually be divided into the following categories. According to the current social development trend and the progressive mode of the distribution network, the traditional power distribution method can no longer meet the needs of social development. The load forecasting method of distribution grade planning is analyzed, including district load forecasting and spatial load forecasting. Suppose that an L2 level network contains n L3 level grades with single function. L is the maximum load of each L3 level grade, and S is the corresponding land use area of each L3 level grade. Then the load density of each L3 layer grade is as follows. Let R be the load weighting coefficient of each L3 layer grade, and K be the load simultaneous rate of each L3 layer grade in the mth year or saturation year. Then the predicted load of the nth year or saturation year of the L2 grade is as follows. Process the collected information, analyze the processing results, and analyze the relationship between the information output and input components. The specific calculation formula is as follows. The normalized calculation formula of input information and output information can be obtained. The formula is weighted to obtain the input data factor expression, as shown in the formula. Load forecasting is to predict the future electricity consumption situation in order to reduce the error and improve the accuracy of the forecasting. The usual practice is to ensure that the completeness and accuracy of the data when collecting historical local data, predict the load of different types and scenarios, and check and correct the forecast results. This improves the accuracy and scientificity of grade planning for the distribution network. The third part is about analysis of experimental results. Based on the analysis and a summary of the current situation of a planned regional power grid, there is still a big gap between the first-class distribution network in the connection rate of medium voltage lines. N-to-1 passing rate of medium voltage lines, average power supply radius of medium voltage lines, insulation rate of medium voltage lines, and power supply reliability rates (RS rate). The load forecasting results of a planning area in the target year are shown in the table. It can be seen that the actual application process, the proposed distribution network grade planning method based on artificial intelligence, has relatively high accuracy for regional distribution network load forecasting, which is basically consistent with the target predicted value. Further comparison is made between the current method and the distribution network grade plan error under this method. It can be seen that the error degree of the grade planning method based on artificial intelligence is relatively low in the practical application process, which proves that the practical application effect of the method is better. The grade planning of the planning area can achieve the following effects. First, the power supply range of the medium voltage line of the distribution network is clear. The target grade and transition grade of the distribution network are strong and reliable. Third, the main planning indicators of the distribution network can reach the level of first-class distribution network and promote the scientific development of the distribution network. Fourth, the planning effect of the above method is obvious, which verifies the effectiveness and scientificity of the method. Finally, it is the conclusion part of the paper. With the increase of social production and domestic electricity consumption, power enterprises must carry out grade planning of distribution network to provide power supply quality of distribution network. This requires that the process of grade planning of medium voltage distribution network strictly follow its planning principles and fully combined with the economic development level of distribution grade region. Continuously promote the grade planning of medium voltage distribution network. In order to ensure that the power supply of the whole distribution network is more reliable and safe, so as to meet the power demand of power users to the maximum extent. That's all. Thank you for your listening.
Hello everyone. It's my great honor to be here to introduce our academic article. The topic is Design of Hotel Marketing Information Management Model based on Deep Learning, which written by Tong from Wuhan Business University, Wang from Wuhan Aiwuyou Technology Co.Ltd. Will be divided into 4 parts. Part 1. The keywords of this article are deep learning, hotel marketing, information management, information extraction, marketing information database. Abstract. The traditional information management model has poor data transmission efficiency in the process of pushing information services. To solve this problem, this paper designs a hotel marketing information management model based on deep learning. using Oracle Relational Database and MVC architecture to build a marketing information database. Then, use deep learning to extract information features and classify marketing information of different service categories. Connect hotel management and client, and integrate model management functions to provide information service for hotel managers and customers. The experimental results show that the data throughput and transmission rate of the above model are higher than those of the traditional model, and the information transmission efficiency is improved. Part 2. Introduction. At present, hotel information management is widely used in hotel operations, digitizing and standardizing the hotel's customer service, material movements, transaction processing, cash flow, customer interaction, and other business processes, enabling the hotel to manage both internally and externally. Significant changes have taken place in all aspects. Therefore, the research on the hotel marketing information management model has important practical significance. American scholars put forward 4R theory, using network technology and resources to carry out network relationship marketing through information communication, so as to grasp the two basic strategies of establishing customer fields and improving after-sales service network, so as to achieve a large range of customized marketing. Domestic scholars analyze the series of 6 marketing models and think that the relationship marketing of enterprises mainly includes employee relationship marketing strategy, customer relationship marketing strategy, partner relationship marketing strategy, and influencer relationship marketing strategy. Among them, employee relationship marketing strategy is the base of the relationship marketing. Customer relationship marketing strategy is the core and the destination of relationship marketing. And then, the corresponding marketing strategy is formulated for each related object. Based on the above points of view, the formulation of relationship marketing strategies should have certain conditions and be carried out step by step. The relationship is maintained and consolidated around the mutually beneficial exchange relationship between related parties and the use of network information technology to establish customer fields and improve field management. On the basis of this theory, this research designs a hotel marketing information management model based on deep learning. The model first used Oracle Relational Database and MVC architecture to build marketing information database. Then, uses deep learning to extract information features, classifies marketing information of different service categories, connects hotel management and the client, and integrates model management functions, so as to provide information service for hotel managers and customers. This study also proves that the model has the advantage of the high data throughput and transmission rate through experiments. Part 3. Design of hotel marketing information management model based on deep learning. The first one is to build a hotel marketing information database. Firstly, we need to build a management model organizational structure. Use the classic MVC model and Oracle relational database to construct the hotel marketing information database. The full name of the MVC architecture is Model View Controller. This architecture pattern processes business data according to the process and scientifically divided data input, processing, and display output into 3 layers, corresponding to the model layer, the view layer, and the controller layer. Second, we need to build marketing information base. On the basis of the design of the model architecture, the Oracle database is used to build a marketing information database. When managers need to manage a large amount of data, Oracle database can be used. Oracle database is typically representative of database technology. It has obvious advantage over the other database in many aspects. It is divided into 2 parts, server and client. When the hotel manager operates the database, he needs to connect to the server and use the database as local database. When managers use database for information access, use the database chain to provide support. Part 3. Experiment and analysis. In order to verify the effectiveness of the hotel marketing information management model based on the deep learning, the following comparative experiments are designed. This paper takes the model as experimental group A, 2 traditional marketing information management models as experimental group B, and the experimental group C. And it completes the performance comparison with this model. Part 4. Concluding. This study designs a hotel marketing information management model based on deep learning, which uses deep learning to classify marketing information, improve data throughput and transmission rates, and can effectively provide information service for hotel managers and customers. But there are still some deficiencies in this study, such as the understanding of some specific functions is not in place. In the future research, we will further expand the functions of the hotel, pay attention to the user experience and customer relationship, and improve the user's experience and the management model. That is the presentation. Thank you. Hello everyone. It's my great honor to be here to introduce our academic article. The topic is Interactive Evolution Model of Industrial Cluster and Regional Innovation based on LSTM, which written by Tong from Wuhan Business University, Wang from Wuhan Aiwuyou Technology Co.Ltd. The keywords of this article are LSTM, Industrial Cluster, Regional Innovation, Interactive Evolution Model. Abstract. The current evolution model of the interaction between industrial cluster and regional innovation has not measured the interaction factors between industrial cluster and regional innovation, which leads to inaccurate changes in the industrial chain supply and demand, input-output coefficients, and industrial quantities. To this end, this study designed an LSTM-based interaction evolution model of industrial cluster and regional innovation. First, use LSTM to measure the interaction factors between industrial cluster and regional innovation, and form a network structure according to the measurement results. Analyze the factor that exist in the interaction process so as to establish the interaction evolution model of industrial cluster and regional innovation. Experimental results show that the model in this paper can better describe the supply-demand relationship and input-output coefficient of the industrial chain in the process of interaction between industrial cluster and regional innovation. Part 1. Introduction. Industrial cluster have the characteristics of geographic proximity and spatial agglomeration, which enable industrial cluster to develop more economic activities and present a good economic development trend. And with the vigorous development of economic globalization, industrial cluster, as a new form of industrial organization, can rely on its powerful resource allocation function to promote the development of regional economy. At present, on a global scale, industrial clusters have become accelerators that promote regional economic development and national competitiveness, and have become the business card, the symbol of their country or region, and have become a ubiquitous organizational form in the developed economies. In addition, industry clusters also provide companies with abundant labor, raw materials, and market orders, which effectively reduce the risk and costs of companies entering industrial cluster to start business, thereby promoting regional innovation. However, the above process is a long evolutionary process, and not all regional industrial clusters can form a good interactive evolution trend. Therefore, this study uses the chain form of long-term and short-term memory network to deal with and predict the interactive evolution process of industrial cluster and regional innovation, and designs an interactive evolution model of industrial cluster and regional innovation based on LSTM. Firstly, the interactive factors between industrial cluster and regional innovation are measured by STM, and the network structure is formed. According to the measurement results, the factors existing in the interactive process are analyzed, and the interactive evolution model of industrial cluster and regional innovation is established. In addition, the model can well describe the supply-demand relationship and the input-output coefficient of industrial chain in the process of interaction between industrial cluster and regional innovation. Part 2. Design of interactive evolution model of industrial cluster and regional innovation. Based on the analysis of the current interactive evolution of industrial cluster and regional innovation in the introduction, it can be seen that there is a direct causal relationship between industrial cluster and regional innovation, interactive evolution, and it's difficult to describe the causality of the interactive evolution process of the industrial cluster and the regional innovation only through large-scale series relationships. Therefore, the interactive evolution model of industrial cluster and regional innovation established in this study will use LSTM to process and predict causal relationships that exist in the interactive evolution process of industrial cluster and regional innovations, and the discovery law form the macroscopic and external environmental connections, thereby completing the industrial research on the interactive evolution model of the cluster and the regional innovation. Part 3. Experimental discussion. In order to verify the application performance of the interactive evolution model of industrial cluster and regional innovation based on LSTM, the following experiments are designed. In the experiments, the effectiveness of the interactive evolution model of the industrial cluster and regional innovation based on the LSTM is verified by comparison. The model in this paper is recorded as a model, and the two traditional interactive evolution models are recorded as B model and C model, respectively, which are used for complete performance comparison and verification with the model in this paper. Part 4. Concluding. This paper designs an interactive evolution model of industrial cluster and regional innovation based on the LSTM, which makes full use of the advantage of LSTM to analyze the factors existing in the interactive evolution process of industrial cluster and regional innovation, and effectively reflects the interactive evolution characteristics of industrial cluster and regional innovation. In addition, the model can well describe the supply-demand relationship and input-output coefficient of industrial chain in the process of interaction between industrial cluster and regional innovation. However, this model doesn't consider the interactive evolution structure and the coupling between industrial cluster and regional innovation, which is not comprehensive enough for the interactive evolution process of industrial cluster and regional innovation. Therefore, in the future research, it is necessary to study the interactive evolution model of industrial cluster and regional innovation, and integrate the interactive evolution structure and the coupling characteristics of industrial cluster and regional innovation into evolution model. That is the presentation. Thank you.
I'm very glad to share my paper design of supply chain resource distribution allocation model based on deep learning with you. Deep learning, resource allocation, supply chain, cost control. Abstract. With the continuous deepening of economic upgrading and transformation, the scope of the supply chain of SMEs has gradually expanded. At present, in the process of supply chain resource allocation, the supply chain resource distribution allocation model is often used to study it. But the cost controllability of this model is poor. For this reason, this research designs a supply chain resource distribution allocation model based on deep learning. Select the indicators of the supply chain resource distribution allocation model to determine the principle of resource input, risk compensation, maximum utility, and comprehensive optimization. Then construct the objective function of supply chain distribution configuration according to the cost and the net requirements, and then use deep learning technology to obtain the optimal solution of the objective function scheme. By comparing the model in this paper with the traditional model, we can see that the model in this paper has better cost controllability. With the continuous maturity of macro-level supply chain collaboration research, such as collaborative mechanism and collaborative technology, how to guide and manage resource allocation among enterprises from the micro level, i.e. supply chain resource perspective, will become a breakthrough in the bottleneck of supply chain resource allocation. 1 to 2. The key to achieve effective resource integration among supply chain members can create greater synergy effect. On the one hand, through the cooperation in material supply, production, distribution, and other links, each member can form the complementary advantages of resources, give full play to their own advantages, enable partners to focus on their areas of expertise, avoid low efficiency, and waste caused by decentralized utilization of resources, and realize the efficient utilization of resources of enterprises. On the other hand, by sharing information, both upstream suppliers and downstream distributors can timely and accurately adjust their own resource allocation according to the market information provided by their partners, so as to respond to the market demand and avoid the loss to enterprises caused by information asymmetry in the traditional market. Therefore, the realization of resource collaboration among supply chain enterprises is of great significance to promote the successful application of supply chain collaboration. At present, the concept of supply chain competition has been widely circulated in the industry and academia. Scholars at home and abroad have conducted in-depth discussions on the supply chain competition and have achieved certain research results. However, through in-depth analysis of existing research results, this article finds that there are still many issues that need to be further explored in the supply chain resource allocation. In addition, the competition between supply chains will further aggravate the uncertainty in the supply chain system, which makes the supply chain system management more difficult. On the one hand, the dynamics and complexity of the supply chain system often frustrate the efforts of enterprises, and the stable system behavior will reduce the cost of the system. On the other hand, as a complex game problem, supply chain competition often has multiple equilibrium solutions. Therefore, how to refine multiple equilibrium solutions and select stable equilibrium strategies for decision makers is also an important research problem. One of the effective ways to solve this problem is to design an effective distribution allocation model of supply chain resources. This study designs a supply chain resource distribution allocation model based on deep learning. By selecting the indicators of the supply chain resource distribution allocation model, the principles of resource input, risk compensation, maximum utility, and comprehensive optimization are determined. Then, the objective function of supply chain distribution allocation is constructed according to the requirements of cost and benefit, and the deep learning technologies use the optimal solution of the objective function scheme is obtained to realize the optimal distribution allocation of supply chain resources. Design of resource distribution allocation model and supply chain. View of the limitations of the current research on supply chain resource allocation. This paper constructs a supply chain resource allocation model with resource allocation and asymmetric supply chain structure, and studies the stability of the game. Cooperation strategies between supply chains and effective strategies to deal with interference events. The design process of supply chain resource distribution configuration model is shown in Figure 1. This paper studies the problem of income distribution among supply chain partners. First, it analyzes the composition of cooperative benefits in the supply chain and the characteristics and principles of the distribution of benefits. Secondly, it focuses on the three main risks that affect the distribution of cooperative benefits in the supply chain. Market risk, technology risk, and cooperation risk. A more in-depth analysis was carried out from four perspectives of risk control and distribution, which provided a basis for the realization of risk sharing and avoidance in the income distribution model. Then, it analyzes and compares the income distribution models from the three aspects of the selection of the optimal plan by these models, the comparison between the models and the application of the models. Based on the self-organization theory and enterprise resource theory, using the methods of synergetics, system dynamics, and economic mathematics, this paper focuses on the conceptual framework, mechanism, and model of distribution allocation of supply chain resources. According to the requirements of cost and benefit, it constructs the objective function of distribution allocation of supply chain resources, and then uses the deep learning technology obtains the optimal solution of the objective function scheme, so as to realize the optimal distribution allocation of supply chain resources. Through the research on the complex adaptability, Anticipative structure, structural model, operation mechanism, evolution process and measurement method of supply chain model. The main conclusions and innovations are as follows. Supply chain resource allocation needs reasonable research on risk. In the process of using supply chain model in the future, this part of the content will be mainly studied in order to improve the use effect of the mode. Thanks for your listening. Thank you. I am Lian-huan College of Finance and Economics, Chongqing Chemical Industry Vocational College. It's my great honor to attend EAI ICMTEL 2021 Third EAI International Conference on Multimedia Technology and Enhanced Learning. I'm very galled to share my paper design of intelligent dispatching system for logistics distribution vehicles based on transfer learning with you. Migration learning, logistics distribution, intelligent vehicle scheduling, vehicle positioning. Abstract. The traditional logistics vehicle scheduling system can only perform scheduling based on static information, which makes it difficult to change the scheduling decision according to the actual situation, resulting in a high logistics distribution cost and poor timeliness of Veneto. In response to the above problems, this research designs an intelligent dispatching system for logistics distribution vehicles based on migration learning. The hardware part of the system is composed of 3 modules: GPS satellite positioning module, GPRS wireless communication module, and ARM central control module, and then uses migration learning theory to locate the vehicle position. Realize the dispatch of delivery vehicles by establishing a dynamic dispatch model. Through comparative experiments with traditional dispatching systems, it is verified that the system in this paper can effectively reduce the cost of logistics and improve the timeliness of distribution, and has certain practical value. Development of the transportation industry and e-commerce, the development of the logistics and distribution industry tends to be informatized, and industry competition is becoming increasingly fierce. The logistics industry is the product of the social and economic development to a certain level. It integrates the warehousing industry, transportation industry, and other complex service industries and is the main component of the national economy. With the improvement of social material living standards, customers have increasingly higher requirements for the timeliness of logistics and distribution. The logistics industry is becoming more and more important in the market economy. To develop the modern logistics industry in a long-term and stable manner, it is necessary to effectively solve the transportation cost problem and optimize the logistics system. Vehicle scheduling problem is the key to optimize the logistics system. In recent years, the vehicle scheduling problem has become a hot topic, which involves many uncertain factors. In the past, a large number of vehicle scheduling studies are based on static assumptions. That is, all tasks or requirements are known before scheduling decision and route planning. Once the scheduling decision is implemented, all situations will not change. This assumption has become increasingly unrealistic in today's rapid development of e-commerce and logistics. However, there are still few research results for more models and algorithms that are in line with the actual situation, such as vehicle routing problem with multiple time windows, vehicle routing problem with consideration of road traffic conditions at different time periods, and vehicle routing problem with both requirements of cargo collection and delivery. Therefore, related scholars have also begun to pay attention to the new research direction of dynamic vehicle scheduling. The core idea of transfer learning is to store and use the knowledge gained in the process of learning tasks in the original field and apply it to the learning tasks in the new target field, so as to improve the performance effect of the target task. Therefore, according to the above analysis, aiming at the problems of traditional logistics vehicle scheduling system, this paper designs an intelligent vehicle scheduling system based on transfer learning. The hardware part of the system designed in this paper is mainly to collect the real-time location data of vehicles, so as to adjust the movement path of logistics vehicles in time. The onboard unit is the hardware part of the whole system, mainly composed of 3 modules: GPS satellite positioning module, GPRS wireless communication module, and ARM9 STM32F101 central control module. GPS satellite positioning module. It is composed of data processing part and antenna, which can receive and analyze GPS satellite message, calculate the longitude and latitude of GPS antenna, carrier movement speed, driving direction, and GPS standard time, which are read by the control module and sent back to the server through GPRS module. GPRS technology has the characteristics of real-time, and the maximum transmission rate can reach 171.2 bits/s, 4 to 5. In this paper, the MG323 GSM M2M Industrial GPRS Communication Unit of Huawei Company is selected to realize the transmission of logistics positioning information. MG323 has 4 communication bands, supports 8-wire serial port, and the sensitivity of data transmission and reception is less than 107 dBm. When MG323 carries out GPRS communication, the maximum downlink transmission rate is 85.6 kbps. The maximum uplink transmission rate is 42.8 kbps, and the data transmission protocol is embedded TCP/IP protocol. Wireless communication module. After the connection with the GPRS network is completed, the data exchange between the onboard unit and the server can be realized. The GPS positioning data of the onboard unit and the status information collected by related sensors are packaged and sent to the server, while monitoring and responding to the remote control sent by the monitoring center to the server and scheduling instructions. 3. ARM Central Control Module. The control center of the entire vehicle terminal, on the one hand, completes the extraction, packaging, and packaging of GPS satellite positioning data, time synchronization data, and vehicle status data. On the other hand, it controls the communication response, voice call, and data transmission and reception of the GPRS module and the monitoring center. At the same time, it responds to various alarm requests of the onboard unit and executes various instructions of the monitoring center, so that the driver can implement corresponding control of the vehicle in time according to the requirements of the dispatch center and perform vehicle-related scheduling tasks. 6. ARM processor controls GPRS module to access mobile GPRS network and then connects to computer monitoring center through Ethernet to realize wireless data transmission. GPS module transmits received data to main control chip through serial port for preprocessing. Flash memory is used to store debugged application program and embedded Linux operating system. On the basis of the above-mentioned system hardware part, the software part of the intelligent dispatching system of logistics distribution vehicles is designed by using the principle of migration learning to complete the system design process and realize the system preset function. Conclusion. An important prerequisite for the stable development of the modern logistics industry is to reduce logistics transportation costs, and the key to solving the transportation cost problem in the logistics industry is to optimize the logistics system. The key step in the optimization of the logistics system is the reasonable dispatch of logistics delivery vehicles. By optimizing the dispatch of delivery vehicles, enterprises can reduce transportation costs and improve customer service levels and economic benefits. This paper designs an intelligent dispatching system for logistics distribution vehicles based on transfer learning and uses transfer learning to effectively improve the reliability and real-time performance of the dispatch system. Through related experiments, it is verified that the system in this paper has practical value. That's all for my paper. Thank you for your listening.
My name is Shiqi. Today my topic is in-flight alignment method of guided projectile based on BDS. My speech mainly includes 4 parts. First, I will introduce research background. Then, I will solve some problems of the current research. Next, I will show the working principle. Finally, I will show the experiment and the simulation about this research. The first part is research background. Precision strike is the key goal of modern warfare. With the rapid development of information technology in the 21st century, many countries have begun to require conventional projectile to be guided and informatized to ensure the effectiveness and accuracy in modern warfare. Guided projectile. The space system can take many advantages. For example, simplify the composition of control system, reduce the impact of structural asymmetry. Traditional initial alignment algorithm for movement takes a long time and requires a simple linear motion of the carrier. Obviously, it cannot be used for the initial alignment of guided projectile of weightlessness, high-speed spinning, and moving in the air. The development history of guided projectile has gone through the following stages. The first stage is laser guidance stage. In 1972, the United States developed the first laser-guided projectile, M712 Copperhand projectile, which using laser semi-active guidance. Meanwhile, Russia developed Krasnopol laser terminal guidance projectile in 1984. Which is better than M712. China introduced it from Russia in 1994 and gradually produced GP6. the infrared millimeter wave guidance stage. Europe and the United States has the most advanced technology. Now, with the rapid development of GNSS, the third generation guidance technology in GNSS guidance technology is playing an important role in the modern warfare. The most representative of them is Excalibur, Mk2, and the WS-35. The accuracy and speed are two indicators for evaluating alignment effects. As for guided projectile, it is necessary to discuss the faster alignment methods. The first method is transfer alignment. It uses the information from the main inertial navigation to help the sub-inertial navigation achieve rapid alignment. But this method is usually used in large tactical weapons. The second method is multi-vector in-flight alignment. It builds multiple vectors and achieves the optimal estimation of CMB according to solve the WABA problem. Meanwhile, in-depth research has been carried out on the estimation method of roll angle for the high-spin projectile. For example, adding geomagnetic sensor using GFMMU and the EKF estimation method. The second part is research problem. There are some characteristics after a guided projectile has been launched. First of all, the overload is no less than 10,000 G while the moment of launch. Then the volume of projectile is extremely limited, and the total flight time is probably 200 seconds. Meanwhile, the rotate speed of projectile is high. For example, 20 revolutions per second. Finally, the trajectory of projectile is relatively fixed. What is working principle? This paper proposes an in-flight alignment method of guided projectile based on INS BDS. The course alignment is proposed based on kinematics equations, and the influence of the Earth's rotation is compensated. Then, on the basis of the traditional 6-dimensional measurement, fine alignment method, the pitch and yaw measurement information are added to construct an 8-dimensional measurement, which can improve the accuracy and the misalignment angle convergence rate. Firstly, we need to clarify the relationship between some coordinate systems: initial coordinate system, navigation coordinate system, projectile coordinate system, and the ballistic coordinate system. Picture 1 and Picture 2 give the relationship between the coordinate systems. At the same time, it is defined that the yaw angle is 0 degree when pointing north, and it is positive from north to west. Then this paper gives the specific derivation process. The position and the velocity of a projectile can easily get from BDS. Due to the characteristics of the trajectory, the pitch angle and yaw angle can be calculated. Theory of external ballistics. The angle of attack caused by the initial disturbance will rapidly decrease, so the following approximation can be used. Meanwhile, the kinematic equation of a projectile body rotating around the centroid tells us the relationship of the gyro output and the attitude of a projectile. For a well-designed projectile, the yaw angle rate after launching can be ignored, so it can be simplified to be equation 1. Combined with equals 2, we can get the table which tells us the unique solution of the yaw angle. On the other hand, by inertial navigation theory, it can be obtained with substituting into the calculation formula of yaw angle. Traditional in-flight fine alignment methods mostly use 6-dimensional measurement to construct the measurement equation. Due to the characteristics of faster rotation speed, fast movement speed, and relatively fixed ballistic trajectory of guided projectiles, the yaw and pitch information derived from BDS speed is considered to construct an 8-dimensional measurement matrix. At the same time, because the 15-dimensional state quantity contains the system misalignment angle, not the actual angle error, it is necessary to build a relationship between the actual angle error and the system misalignment angle. The final part is the experiment and the simulation about this research. Before verifying the above algorithm, we need to design the ballistic trajectory. This paper sets the ballistic parameters as follows. It includes the simulation step, the initial information, and the other parameters. Meanwhile, it is necessary to set simulation error parameters, including gyro Bayes error, accelerometer Bayes error, angle random walk, speed random walk, and others, in order to verify the in-flight course alignment method of guided projectiles based on kinematic equations proposed in this paper. It first used the guided projectile trajectory generator to generate ideal gyroscope and accelerometer data. Then, this paper ends the corresponding error according to the actual situation. The trajectory parameters of a trajectory generator are used as true values for comparison. This paper gives the experiment and comparison of course alignment methods. The left figure shows the pitch and yaw errors of the guided projectile. The right figure shows the alignment error of the yaw angle, after compensated for influence of the Earth's rotation, and which is not compensated. It shows that if the effect of the Earth's rotation is not compensated, the yaw angle alignment result would have a drift of more than 1 degree. This paper gives the experiment and comparison of 5 alignment methods of the two methods. The left figure shows the in-flight fine alignment error of 8-dimensional measurement. The right figure shows 6-dimensional measurement. There are 4 subfigures in each figure. Subfigure shows the east misalignment angle and the north misalignment angle. The second subfigure shows the sky misalignment angle. The third subfigure shows the speed errors. The last subfigure shows the position errors. It gives the details about the fine alignment error in the form of RMSE. It can be seen that, after ending the pitch and yaw measurement information, the eastward speed error is reduced by 0.044 meters per second. The northward speed error is reduced by 0.1 0.56 meters per second, and the sky speed error is reduced by 0.126 meters per second. The eastward misalignment angle error is reduced by 2.1 degree. The northward misalignment angle error is reduced by 0.7 degree, and the sky misalignment angle error is reduced by 0.86 degree. Simulation experiment shows that the speed error and the misalignment error of the new in-flight fine alignment method are significantly reduced, and the convergence speed is also significantly faster. Thank you for your attention. If you have a question, welcome to communicate with me.
Everyone, my name is Zhen. I'm from Southeast University, China. Today, my topic is verification of deformation measurement method based on FPG sensor. I will introduce the topic in 3 parts. Now, the first part is research background. Please look at the picture. Nowadays, structural health monitoring has always been an important research area in the field of airspace. The deformation extent of aircraft wing directly affect the flight safety of aircraft. In 2003, the helices of the NASA suddenly broke up in the air during a test flight. The investigation results show that the main reason for the wing disintegration in the air is the use of inappropriate analysis methods to evaluate the wing layout design, which makes helices very sensitive to turbulence. This case reminds us of the importance of structural design and real-time dynamic measurement of the aircraft during flight. Please look at the picture 2. Now, under the background of optical fiber sensory technology, the USA Marine Corps has begun to use a new fatigue live tracking method to record the real flight load on the aircraft, which can effectively track the structural dynamic deformation of the aircraft and helps to extend the service time of the aircraft. Real-time online detection of wing deformation plays an important role in ensuring future safe operation of aircraft. The additional weight caused by strain gauges, signal transmission cables, and signal processing unit cannot be ignored. Researchers has done a lot of research on the application of the new generation of optical fiber sensors in aircraft deformation measurement. FPG has been widely used in deformation measurement of large structures due to its small size, lightweight, strong anti-electromagnetic interference ability, and self-turning function. Now, let me to introduce the second part, research status. In 2010, the researchers of Germany developed a strain calibration device which can provide reference strain conditions with less uncertainty without using electric strain gauges. This device, everyone can look at the figure 4. It can provide a reference strain condition with a relative uncertainty of about 0.3%. The relative standard deviation of calibration measurement for the same type of IPG sensor is about 0.16%, and there are significant differences in strain sensitivity between the two sensors. Please look at the figure 5. Researchers in 2011 from Germany has developed a calibration test device for FPG. The unbiased digital imaging calibration and electronic speckle interferometer are used for calibration measurement, and the resolution of DIC is 2, and the ESPI is 30. The experimental result shows that this method designed by researchers is a non-contact method which can measure displacement and strain in all directions. This method can analyze the strain transfer mechanism and observe the relative motion between sensors and samples easily. Please look at the figure 6. It is a calibration setup. Researchers designed this non-destructive calibration method for FPG sensor using magnetic nano-motion sensor. Researchers designed a customer-sized calibration device which used a dual-tail slide weight mechanized by stepping motors. Through the analysis of experimental data, the performance of FPG strain sensor is studied. The calibration curve of FPG sensor is given, and the feasibility of this method is demonstrated. Now, I will introduce the third part. The third part is about the experimental analysis in our topic. Please look at the figure 7. This is the wing structure or structure diagram of our topic. Considering the irregulation of wing beam section structure, two sides of the simulated wing are contacted by splicing and fixed on the motion simulation platform with upper pressure plate. The upper surface of both wings are designed to be streamlined, which accords with the rear wing model characteristics. This wing structure diagram in Figure 7 is designed by software SolidWorks. And the blue line, please look at the picture. The blue line in the figure is the cursive position of IBG, and the numbers in the picture is the center wavelength. After designing the wing structure, we do the data analysis. Due to the asymmetric cross-section of the wing structure, the closer to the root of the wing, the greater the shear force is. Bending moment and torque on the cross-section are. In the experimental design, the density of FPG sensors is increased at the root of the wing, and 4 FPG sensor arrays are laid at the root with a spacing of 10 cm. The remaining 10 FPG sensor nodes are laid at the far end with a spacing of 20 cm. 2 FPG sensors are inserted on the thickness part of the upper and lower surface of the wing. The experimental arrangement is shown in Table 1. Please look at the Table 1. This is measurement experiment screen. Now please look at the Figure 8. This is a physics picture of experimental platform. The loading method is adopted in the experiment process. The load is continuously applied to one end of the wing to 3 kg. The experimental platform is built in the picture and put on in our experiment center. Please look at Figure 9. This is the string fitting results. The FPG demodulator is used to collect the wavelength change data of each point on the upper and lower surface, and make difference with the original wavelength of the corresponding point. At the same time, the strain value of the upper and lower surface is obtained by combining the formula and the difference value of the strain center of the upper and the lower surface is taken as strain value under the corresponding load. The strain change data obtained in step 1 is used to fit the relationship between strain and time, as shown in Figure 9. It can be seen from the figure that as the pressure increased, the strain is gradually increased, and the closer to the root, the greater the strain is. Please look at the figure 10. This is displacement fitting result. Combined with the height change data of each point of the wing measured by micrometer. The change data of height change data are fitted to obtain the relationship between wing shape, vibration, and position, shown in Figure 10. By analyzing, we can know that the figure area of wing tip deformation is gained in Table 2. By using the fitting model to calculate the shape of the wing at each time, the paper used finite element analysis to verify the accuracy of the deformation displacement model of the wing measured by FBG. In Table 2, it can be seen that the error between the fitting value of deformation model based on FBG sensor and the result of the analysis is less than 1 micrometers. By the analysis in those two parts, we can get the conclusion that the paper analyzed the influence of aircraft wing mechanic structure and aircraft structure force transfer on flexure baseline structure. Based on structure mechanics, the deformation motion law of flexible baseline under interference environment is obtained, and a high precision deformation model method of flexible material baseline is approached. Combined with the finite analysis method, the feasibility and measurement accuracy of the measured are verified by experiment, and the maximum error is less than 1 micrometers. That's all. Thank you very much. Thank you for your listening.
Good morning, everyone. I'm Zhang Si from School of Instrument Science and Engineering, Southeast University. I appreciate the opportunity to be here to give this presentation. My topic is about motion-constraint aided underwater integrated navigation method based on improved adaptive filtering. Today, my presentation will be divided into 5 parts: research background, research problem, working principle, systematic design, and simulation results. Now, I will introduce the research background briefly. 70% of the Earth's surface is covered by the ocean, which has abundant biological and mineral resources. As a naval submarine, autonomous underwater glider plays a significant role in marine environment monitoring and underwater source exploitation, such as ocean environment modeling and resource exploitation, underwater target detection and identification, ocean rescue, and the installation and maintenance of ocean pipelines and cables. The picture shows the Qianlong-2 autonomous underwater vehicle. This type of underwater vehicles often rely on their own power source and intelligent devices for navigation. They don't need capable connecting, widening, and has wide range of activity as well as wide detection area. Besides this, AUVs also have the advantages of low noise, high concealment, small size, which make them irreplaceable. The second part is the research problem. No matter whether the underwater vehicle is walking on the surface or under the water, there are three common problems. The first one is initial alignment. The second is that the filtering performance becomes worse under the condition of turning and obstacle avoidance. The third is anti-jamming adaptive algorithm. But for the underwater vehicle on the water surface, the GPS signal is often out of lock due to environmental factors. As for the underwater vehicle under the water, the combination accuracy will retention when the DVL measurement information goes wrong. Usually, underwater vehicle will glide in sawtooth waves on the bottom of the sea. During the gliding process, if it encounters submarine ditches, clusters of fish, or strong maneuvering turns, the measurement information provided by the Doppler will be wrong, and the preset measurement noise matrix will not be able to adapt to the disturbed model, which will affect the accuracy of positioning. In order to solve the above problems, this paper introduces the centripetal acceleration constraint and the improved Husa adaptive algorithm to assist initial Doppler integrated navigation. When the underwater vehicle encounters submarine trenches, fish schools, and strong maneuvering turns, and the Doppler measurement information is wrong, the centripetal acceleration will be introduced to restrict the speed of the underwater vehicle, and the improved Husa adaptive filtering algorithm will be adapted to reduce positioning error and improve positioning accuracy. In the third part, working principle will be presented in brief. Single beam DVL calculates the Doppler shift by the difference between the transmitted and received frequencies. As for a 4-beam DVL, 2 pairs of transducers are installed at the bottom of the vehicle, and the beam is emitted in 4 directions. The Doppler frequency shift is obtained by measuring the frequency of the transmitted beam and the frequency of the reflected beam. The velocity of the underwater vehicle in the 3 directions of the carrier coordinate system is obtained as Formula 4. According to the above formula and the picture on the PPT, the error model of Doppler log can be obtained as Formula 5, where Vd is the forward speed of the underwater vehicle, c is the speed of light, Vx, Vy, and Vz are the speeds in the 3 directions of the submarine carrier coordinate system. F0 are the transmitted wave frequency. FD1, FD2, FD3, and FD4 represent the Doppler shift. Alpha are the transmitted beam inclination. Delta V du, delta V dE, and delta V dN are the velocity arrows of the three directions of the submarine in the east-north-up coordinate system. Delta Vd are the Doppler velocity measurement arrows. Beta are the pitch angles of the submarine. Delta C are the scale factor arrows. Kd, gamma, and delta delta are azimuth misalignment angle and drift angle arrow. The operating environment of the submarine is usually more than 10 meters underwater, and the wave flow is relatively gentle. It can be considered that the two directions of the submarine perpendicular to the forward speed are only related to the seawater velocity, and assuming that the velocity is zero. The constraint conditions can be obtained as Formula 8. And because any motion of the submarine can be decomposed into a plane perpendicular to the z-axis and a plane perpendicular to the x-axis, as shown in these figures. According to the kinematic formula, we can get Formula 9. From the initial devices, Formula 10 can be obtained. So the motion constraint after introducing centripetal acceleration is shown as Formula 11. Take the east-north-up coordinate system as the navigation coordinate system. Velocity under the body system can be represented as Formula 12. Formula 13 and Formula 14 represent the carrier velocity arrow model and constraint vector of centripetal acceleration, so that the arrow model is further obtained as Formula 15. In traditional Kalman filtering, the formula for measuring prediction arrow is shown as number 16. Find the variance on both sides at the same time to get Formula 17. Using exponential reduction memory weighted average method, we can get Formula 18. Traditional Sachs-Husserl filtering considers as Formula 18, where B is the fading factor, but as the number of filtering K increases, it will approach zero, and the weight of adaptive filtering will remain unchanged. At the same time, the distribution weight of the initial measurement noise vector gradually decays and approaches the constant value zero. The above-mentioned reasons reduce the adaptive degree of the noise estimator, and the accuracy of filtering will decrease accordingly. According to the prediction residual method, it is possible to artificially judge whether the filtering is divergent. If the filtering is normal, the general filtering is performed. If the filtering divergency is detected, the optimal value is calculated in real time to prevent the divergency of the filtering. The filtering divergency criterion is shown at Formula 19. When gamma equals 1, the strictest convergency criterion will be established. Finally, the optimal delta K can be obtained as Formula 21. The first part described the systematic design of a motion-constraint-aided underwater integrated navigation method based on improved adaptive filtering. Here gives the state equation, measurement equation, state vector, measurement vector, and the filtering equation, which can be described as Formula 22 to Formula 31. Among the filtering equation, the state transition matrix, the measurement matrix, and some other matrix definitions are shown in this page of PPT. The final part is simulation results. The comparison of simulation results will be carried out in this section. In order to verify the accuracy of the algorithm, this article sets up a simulation experiment based on the MATLAB platform, in which the initial original indicators and the initial navigation parameters are set as follows. Generally, the submarine often glides in sawtooth waves at the bottom of the water. In order to simulate the navigation state of the submarine, this article first conducts the trajectory simulation of the submarine. The simulated travel time is 1029 seconds, including constant speed, uniform acceleration, uniform deceleration, heading angle change, pitch angle change, and roll angle change. Combining the above parameters, using the motion constraint-aided underwater integrated navigation method, based on improved adaptive filtering proposed in this paper, the velocity arrow and position arrow of the carrier are shown in this page of PPT. Calculate the root mean square error of the submarine velocity and position based on the algorithm proposed and the standard Kalman filter method. The results are as shown in this table. It can be seen that the improved Sachs-Husa adaptive filtering algorithm with additional motion constraints constrains the three-directional speeds of the carrier and adapts the measurement noise, which can well suppress the divergence of the combined system error and greatly improve the navigation accuracy of the system. In order to verify the improved performance of adaptive filtering in the case of filtering divergence, the measurement noise was added 10 times from 600 seconds to 610 seconds. The final speed arrow and the position arrow of the submarine are shown in this page of PPT. Calculate the root mean square error of the speed and position of the submarine under the two methods of standard Kalman and motion constraint aid based on the improved Sachs-Husa adaptive filtering algorithm, and the results are shown in this table. It can be seen from the table that, due to the sudden increase of measurement noise and the divergence of the standard Kalman filter, the trajectory of the submarine cannot be accurately estimated, resulting in the continuous increase of the speed and position arrows of the submarine. But the motion constraint-aided underwater integrated navigation method, based on improved adaptive filtering proposed in this paper, can suppress the filtering divergence very well, and has better fault tolerance, and the accuracy is much higher than the standard Kalman filtering algorithm. That's all. Thank you for listening.
design and the implementation of financial management analysis based on big data platform of psychiatric hospital, Suzhou Guangji Hospital, Meiyingsu. Contents: Introduction, Research status, Financial management function requirements, platform outline design, summary. At the end of 2018, the number of permanent residents was 10.7 million, of which the population of household registration was about 7 million, and the floating population was 3.8 million. 10 counties under its jurisdiction, 36 streets, 53 towns. Guangji Hospital of Suzhou City is a Class 3, Class A hospital in Jiangsu Province. Guangji Hospital of Suzhou City is a psychiatric hospital with a history of more than 90 years, and it is also the only at the same time as a main technical support unit. The hospital has undertaken the National Severe Mental Illness Prevention and Treatment, Suzhou Psychological Assistance Hotline, and the construction of the National Model Mental Illness Community, rehabilitation stations, and the establishment of a national demonstration area for comprehensive management of mental health. Introduction. The improvement of the level of medical services is inseparable from the construction of medical information. With the rapid development of information technology, more and more hospitals are accelerating the implementation of various information construction projects based on the Medical Information Platform (HIS) system of artificial intelligence, big data analysis, and the Internet of Things to improve the core competitiveness of hospitals such as service level, medical quality, management level, and financial indicators. Informatization can not only improve the efficiency of doctors, but also allow doctors more time to serve patients, improve the hospital's management level and comprehensive development strengths, and show the image of a high-tech hospital. The improvement of financial management level also depends on the development and construction of information technology. Research status. At present, the characteristics of financial data collection, the diversity of various systems in the hospital, each system is separated, and the system is closed, forming an information island. Various systems generate a large amount of data, but the data utilization rate is low, and the degree of sharing is poor. Data collection related to multiple systems is difficult, and there is no unified channel. The reports generated by each system are single and the usability is poor. Financial management function requirements. Public welfare is a characteristic of public psychiatric hospitals. The source of funds for hospitals is also the financial balance allocation. Public welfare is a basic principle that must be used in the process of carrying out various medical activities. Hospitals undertake a large number of public functions such as prevention, intervention, rehabilitation, publicity, and education of mental and psychological diseases, rather than simply for obtaining more economic benefits. Therefore, in the process of financial management, public psychiatric hospital should consider how to maximize the use of funds, reduce operating costs as much as possible, and ensure that the benefits they can obtain are always within a reasonable range and will not increase. The burden of patients is of great significance to the sustainable development of the hospital. First of all, the results of financial management can reflect the status of the hospital in terms of operation, capital flow, and profitability, and then continue to adjust the management method. Secondly, through financial management, we can better achieve the financial budget goal, that is, to ensure that the financial structure is always scientific, which also helps managers understand the shortcomings and of the hospital in the operating process, and then rationally allocate resources. Third, through the results of the first stage of financial management, a preliminary estimate of subsequent benefits can be made. Fourth, public psychiatric hospitals must not only follow the basic principles of public welfare, but also ensure the reliability of income. This requires cost accounting to be controlled to minimize operating expenses. Medical information system. Structured electronic medical record system. Nursing management system, EEG system. Medical image system. Office. The system has 18 data sources as a big data integration platform. Create a set of storage devices through the ODC data storage tool to store the basic business database and the operation process data ODS. Through the above physical architecture and data storage as the underlying framework, a big data integration platform for Guangji Hospital is built. Business functions. Dynamic revenue and expense analyze function, financial management analyze function, quality cost control function. With the promulgation and implementation of the national financial management regulations and the advancement of the general accounting system, the development of modern financial management requires the introduction of traditional financial accounting management models into the era of knowledge economy, taking the opportunity of information development and the constructing of big data platform to realize the upgrade of financial data analysis, statistics, management, and other functions. Update the concept of financial management to meet the needs of hospital administrators for science and fund management. Thank you.
Hello everyone, my name is Feng Jidong from University of Jinan. My topic is design of an interactive LiDAR-vision integrated navigation system. There are three main parts to what I want to talk about. The first part, introduction. The second part, a hardware design method combining LiDAR and vision location. The last part, conclusion. Part 1. Introduction. With the rapid development of society today, with the multitude of technologies and the needs of production and life, the application of mobile robots is more and more extensive compared with traditional human work. Unmanned mobile robot is more efficient, more convenient, and can adapt variety of different environments. The development of robots cannot be separated from navigation. Accurate and efficient navigation can help robots complete their task better. Nowadays, the main navigation methods include LiDAR navigation and visual navigation, each of which has its own advantages and disadvantages. LiDAR navigation technology has the advantages of simple structure, long life, and high accuracy in short range. Visual positioning can obtain more information about the surrounding scenes. In this work, a hardware design method combining LiDAR and vision location is proposed. Part 2. A hardware design method combining LiDAR and vision location. The hardware part of the whole system consists of 6 parts. LiDAR navigation module, binocular camera positioning module, mobile robot motor control module, power module, communication module, and a host computer. The batteries power the LiDAR, the binocular camera, and the motor. The current, velocity, acceleration, oil engine, and other data are acquired by the LiDAR and the binocular camera. When the robot moves, then the data is processed by the communication module and transmitted to the upper computer. Let the operator know how the robot is moving. The LiDAR module is Shilan. It is a 360-degree laser radar developed by Slim Tech Company and is able to achieve 360-degree laser scanning within a radius of 12 meters. This has met the needs of mobile robot positioning under most indoor conditions. Xiaomi binocular camera D1300 color. The camera has a 60 fps frame rate, a 2560 product 720 resolution for regular images and a 1280 product 720 resolution for deep images. It also supports infrared model and can take infrared images. The experimental platform with LiDAR and binocular cameras is the official Rose Turtleboat 2. Turtleboat 2 is a platform designed to provide experimental environment for different robot projectiles Under indoor conditions, the mobile robot can move horizontally and rotate 360 degrees in all directions to from complex trajectories to verify the accuracy and stability of the two methods of positioning and navigation combined with LiDAR and vision. The last conclusion. To solve the indoor mobile robot positioning navigation accuracy problem, the paper presents an integrated navigation hardware design that combines LiDAR and virtual positioning. The position and pose information of two groups of mobile robots are obtained through two navigation models. Then, the host computer fills the information to calculate accurate position in real time. There are some points can be future improved. For example, as more modern machine learning based information fusion method can emerge and shows greater results. Besides, as the information from different systems is not totally trusted, so belief theory can be used to mine deeper information and make decisions. We are planning to investigate them in our later work. Thank you very much.
Hello everyone, welcome to my presentation. My name is Guan-hua. I'm studying in Southeast University, majoring in instrument science and engineering. It is my honor to have this opportunity to make this speech in EAI ICMTEL 2021. The topic of my paper is high precision calibration and error estimation of RLG things. Ring laser gyroscope strap-down inertial navigation system. The outline of my speech is as follows. The first part is introduction. The second part suggests error model. In this part, the error models of quartz flexible accelerometers and laser gyros are established at first. Then, according to the principles of things error equations are derived. The third part describes the systematic calibration method. In this part, a multiple position rotation error excitation method, and a 33-dimensional Kalman filter are designed for the high precision estimation of error parameters under both static and small angle swing basis. The first part shows the simulation experiments for the systematic calibration under both static and small angle swing conditions, including error estimated results and compensation performance analysis. The fifth part gives the conclusion of the systematic calibration method. The first part is the introduction. This picture is a scene's navigation schematic. The scene uses 3 laser gyroscopes and 3 accelerometers to measure the angular velocity and specific force respectively. Then, based on the dead reckoning principle, scenes calculates the heading, attitude, velocity, and position information continuously. According to scene's navigation principle, it is obvious that inertial navigation is a fully autonomous navigation technology. Therefore, inertial navigation has characteristic of accumulating navigation errors over time, which leads to the result that since calibration has great influences on navigation accuracy. Therefore, studying since calibration technology is necessary. Since calibration method mainly include discrete calibration and systematic calibration. Discrete calibration calibrates output errors separately and requires the attitude of the IMU accurately known, which limits the application of discrete calibration. Systematic calibration is widely researched worldwide. Systematic calibration calibrates error parameters simultaneously and allows the specific attitude of IMU unknown, which reduces dependence on the accuracy of turntable. Systematic calibration is also a good online calibration method and has its research value. These two papers mainly studies the systematic calibration under both static and small angle swing basis. A 33-dimensional Kalman filter is designed, and a multi-position rotation error excitation scheme is introduced to calibrate inertial sensor errors, including bias, scale factor errors, and misalignment of both gyros and accelerometers, and quadratic errors of accelerometers. Simulation experiments are performed under both static and small angle swing basis to verify the effectiveness of this method. The results show that this method performs well and has its value in online calibration of slight swing conditions such as ship mooring state and mirror launcher swing state. Next, let's introduce the error model. Firstly, I will introduce the sensor error model. The inertial sensors of RLG scenes are composed of the 3 laser gyroscopes and 3 quad flexible accelerometers. The first formula is gyro error model, including bias, scale factor errors, and misalignments of gyroscopes. This formula uses the sum of the bias and the product of the measured angular velocity and the error matrix to express angular rate errors. The second formula is accelerometer error model, including bias, scale factor errors, misalignments, and the quadratic errors of accelerometers. This formula uses the sum of the bias, the product of the measured specific forces and the first-order error matrix, and the product of the quadratic terms of the specific forces and quadratic errors matrix. In the cases of small angle swing, the nonlinear error of accelerometers may have a great impact on the inertial navigation accuracy. Therefore, on the basis of traditional inertial sensor error model, the quadratic errors of accelerometers are added to achieve high precision calibration under both static and small angle swing basis. Sensor error model establishes the relationship between inertial sensor errors and measurement errors of inertial sensor. Then comes to the since error model. There are errors between idle navigation coordinate system and extra navigation coordinate system. In order to reflect the changes of error angles between these two coordinate systems, the first formula, since attitude error equations are established. Similarly, the second formula, since speed error equations are established according to the errors between the idle speeds and the calculating speeds. Since error model establishes the relationship between navigation errors and measurement errors of the inertial sensor. So far, using 4 formulas presented in error model section, the relationship between navigation error and inertial sensor error has been established. In the following chapters, according to this relationship, I will give navigation errors as a quantitative measurement to estimate error parameters and realize systematic calibration. Next section is systematic calibration method. Systematic calibration usually uses navigation errors as a quantitative measurement to estimate all error parameters simultaneously through calculation, which depends on the relationship between navigation errors and inertial sensor errors, which has established in previous section. In this section, firstly, I will introduce the systematic calibration process. The systematic calibration flowchart is shown in this figure. The overall systematic calibration steps are as follows. At step 1, IMU rotates according to the rotation error excitation scheme, which will be introduced in the following part. Meanwhile, the system collects the simulated output signals of IMU. Step 2 calculates the navigation speed errors in RLG sinks. At step 3, the speed errors are input into Kalman filter as a quantitative measurement. Then the system continues Kalman filtering until all the collected data are traversed. Step 5 feedbacks the estimated error parameters to compensate the output signals of inertial sensors. Repeat the process from step 2 to step 5 until all the preset number of the iterations is reached. Finally, output final calibration results of the estimated error parameters, which are used to compensate original IMU output data. In this section, next, I will introduce rotation error excitation scheme used in systematic calibration method. The multi-position rotation error excitation method is used to excite sensor errors under both static and small angle swing basis. This figure is a 10-position rotation error excitation scheme. At the inertial moment, the coordinate system of IMU coincides with the navigation coordinate system. Then the IMU rotates according to the scheme in this figure. The rotation speed is 10 degrees per second, and IMU stays stationary at each position for 10 minutes to fully stimulate the errors. After rotating 9 times and staying stationary at 10 positions, there are additional rotations to make IMU rotate 720 degrees around each axis at last and return to the inertial postures, which helps to observe the errors. In this section, finally, I will introduce Kalman filter. In this part, a 33-dimensional Kalman filter is designed for the estimation of inertial sensor errors. This figure describes Kalman filter calculation process. The figure contains 5 Kalman filter equations. In this figure, the Kalman filter is divided into 2 loops, filtering calculation loop and gain calculation loop, and 2 stages, time update and measurement update. The first formula is state equation of Kalman filter, where X is the state quantity, including attitude errors, speed errors, besides bias, scale factor errors, and misalignments of both gyros and accelerometers, and quadratic errors of accelerometers are also included. F is system state matrix, which is obtained by error model introduced in previous section. G is system noise output matrix. W is measurement noise of Gaussian white noise model. The second formula is observation equation, which takes velocity errors as the observation written as Z. H is observation matrix. V is system observation noise of Gaussian white noise model. So far, a complete systematic calibration method has been designed. Next section is about calibration simulation experiments. Calibration simulation experiments will be performed under both static and small angle swing basis based on systematic calibration method designed above. This page shows the trajectory simulation results of multi-position rotation error excitation method under both static and small angle swing basis. Figures on right side show trajectory simulation results and simulated IMU output data under small angle swing base. It can be seen from the trajectory simulation results that the speed on each axis are always 0 meter per second. The angles change according to the preset rotation scheme, where small angle swings are added. The small angle swings can be observed more clearly in the third figures. Figures below shows the simulated output data of gyros and accelerometers. Figures on left side show trajectory simulation results and simulated IMU output data under static basis. In this case, there is no impact of small angle swing. This page shows the comparison results between calibration estimated value and the preset error value under both static and small angle swing basis using systematic calibration method designed in previous section. Results in the table show that the calibration accuracy of each error parameter under static and small angle swing basis is basically the same. The relative errors of simulation calibration experiment results basically don't exceed plus or minus 0.1%. The systematic calibration method introduced in this essay has high calibration accuracy. Inertial sensor errors calibrated by systematic calibration method is used to compensate inertial sensor measurement data and optimize inertial navigation accuracy. Navigation results after compensation are shown in the figure. The first three figures on the left are navigation results of altitudes, and the fourth one is navigation results of speeds. In these four figures, results after error compensation are red, while results before correction are blue. Figures on the right show the changes of altitude errors and velocity errors during filtering. Navigation compensation results show that the calibration and error compensation make speed errors and altitude errors not increase significantly with IMU rotation movement and the increase of time. Besides, after error compensation, the calculation results of altitude and speeds also improve to a certain extent. Therefore, this system calibration method has a good compensation performance. Last part of my speech is a conclusion. Firstly, the error model, including sensor error model and scenes error model, is established. Next, the systematic calibration method under both static and small angle swing basis is designed. In this section, Systematic calibration process is described at first to give a whole view of systematic calibration method. Then, multi-position rotation error excitation scheme is introduced to excite errors under static and small angle swing basis. Besides, a 33-dimensional Kalman filter is designed to estimate error parameters. Finally, calibration simulation experiments using systematic calibration method are performed under both static and small angle swing basis to verify the validity of this high precision calibration and error estimation method of RLG things. Simulation experiment results show that calibration accuracy under static and small angle swing basis is basically the same. Moreover, relative error of simulation calibration results basically don't exceed plus or minus 0.1%. Besides, compensation of calibration error parameters also improve the navigation performance in simulation experiments. Systematic calibration method in this essay has certain reference value in online calibration applications under ship mooring state and mirror launcher swinging state. These 2 pages show the references in this paper. This is the end of my speech. Thank you for watching. If you have any questions, please feel free to communicate with me.
It's my great honor to introduce our research result to you. Our team's research direction is in the field of rehabilitation robots. The title of our paper is PD Container of a exoskeleton robot based on the slowly made RBF neural network. It will be planned from the following 4 parts: introduction has data acquisition, container design, and conclusion, which practically with the coming of the agent socially, the number of people will psychopath disabilities has caused by has spinal cord injury, brain injury, and our diseases will increase rapidly. Then, the development and application of rehabilitation robots are incorporated to provide partial technology support for solving the problems of elderly core disability, assistance, and rehabilitation. Due to the complexity and strong coupling of human gait. It is difficult for LLER to be more comfortable and sufferly for trading in this course. Your paper prepares a kind of PD container of LLER based on learning mode RBF have neural network. In order to verify the effectiveness of the pre-processed container part not experiments were carried out. The data of the subject was collected through the motion capture system. Simulated model was established based different country methods like convolutional SMRBF neural network container and PD container based on SMRBF neural network have been tested on the LLER. The experimental results shown right. The container prepared in this paper can not only make LLER trick to the human body gait trajectory, but also output operator and took when there is disturbance. So this paper employs a container scheme that combines SMRBF neural network with PD to matter at human gait trajectory as shown figure 2. The creator mainstream gait data acquisition equipment is based on the measurement methods of height-bound optical cameras to capture the trajectory of the market. This paper uses knocker optical motion capture system like race. As shown in the figure 3, the subject human joints are labeled with marker points, and the motion capture system will capture the gait trajectory of the subject working in the experimental process. The captured data needs to be smoothed naturally by the correct statistical software and then the human data is derived is race. Data is race. After the data processing the joint data of each joint is obtained as important of the country system. because of the symmetry something of data merging the dynamic model of data can be simplified to make a model with paper use longer mercy to establish the exoskeleton dynamic model like race the M, C, and J are known, but the M0, C0, and G0 are unknown. Of course, we can use another machine. I think the dynamic model your press can be rewritten as no race. The RBF neural network is used in the paper. It have three layers, namely the important layers, the hidden layers, and the output layer. Shows the Gaussian function as the allocation function of the RBF neural network. The output of the RBF neural network is race. W is the weight of the RBF neural network. At some time, we designed the container rate of the wheel system and adaptive neural of RBF neural network. The network is this. Then we analyze the stability of the system, establish the flowing function accuracy, and prove that the system is progressively stable. Then express through experiments the design straight joint angles of the hip and knee, and the joint are obtained from the human gait trajectory by the motion capture system and designed parameters in the contours is determined as flow is race. That's in order to highlight or better the contrast in the simulation. The simulation experiments will use the conventional RBF neural network containers and PD container used based on SMRBF neural network. The joint trajectory taking state when using the RBF neural network container the accuracy between the ideal joint and the real joint. The real joint is more than 0.0 and the real file read process firmware conventional hardware SMRBF neural network container has high frequency tick like race. That's bad. But joint trajectory taking state when using PD container based on SMRBF neural network train accuracy rate between the ideal joint and real joint and radial joint is net run 0.010 z/s. The output torque is smooth and more in race with the correct practice of human motion taking into account right if the practical application using the PD controller based on SMRBF the neural network will be better than just using the SMRBF neural network container. The container knows the LLER2 knows the normal human gate from rehabilitation trading where ensuring the smooth and super output torque. Our special trading is as follows. The machine corrected the reticles of LLER analyzed and human gate data is communicated by the machine capture system in this paper. The most important thing is right this paper has proposed a PD container based on the SMRBF and neural network and the controller knows the LLER2 knows the human gate for rehabilitation training where ensuring the smooth and super output torque. It is verified by manual simulation that the output joint angle of the LLER can quickly track the desired joint angle compared with the traditional SMRBF neural network. The container strategy proposed in the paper has small joint angle errors, and the output torque is small and more component. But the result has also some shortcomings to be improved. Firstly, the following two projectors parted in the experiments, and the result of obtained are less generalized. Second, LLER can't show country strategy based on human movement. Intention will require more subjects for data connection and induction introduce EEG and EMG cycles to predicate human gait in the future.
My topic is research on residential power consumption behavior based on typical load pattern. Introduction. Non-intrusive load monitoring analyzes the operating status of various electricity equipment in the tested households through data monitoring of the electrical load port signals of the household users. The correct monitoring of the electrical load of the household users has an impact on the health of the user's home in terms of power supply demands. Through the analysis of users' power consumption behavior data, the power system can be more reasonably divided into time periods and power consumption to set electricity prices and improve the utilization of power system assets. This is the daily load curve of household electricity. 2 parts. Application of traditional Fuzzy means clustering in the study of electricity consumption section. Fuzzy means clustering divides n vectors into C fuzzy groups and finds the clustering center of each group to minimize the value fraction of the dismissibility index. The main difference between FCM and HCM is that FCM uses fuzzy division, so that each given data point uses a degree of membership between 0 and 1 to determine the degree to which it belongs to each group. After completing the data collection function, the data in this study were mainly concentrated in 89 power load points, and 10 different time points were collected for different load points, and a total of 418 power consumption data were analyzed. From the analysis of the clustering results, it can be found that in traditional clusterings, there are more noise points, and the classification and clustering results are not obvious in combination with the current electricity nodes and loads. 3 parts. Application of improved fuzzy means clustering in the study of electricity consumption. In the traditional fuzzy means clusterings, there will be more noise points, that is, for some electricity consumption data. Therefore, data pricing is required in this part, combined with artificial neural network (BP neural network) to classify and process the data. From the above comparison, some node data has a large gap. At the same time, for the node data, due to the particularly of the electricity consumption data, it can be found that the electricity consumption data is relatively large, which will be affected to a certain extent in the subsequent calculation and analysis. In order to better calculate the difference between the samples, use the working day date as A and the result date as B, and use the following formula to calculate the difference value as an evolution indicator. After performing the same processing on 89 nodes, it can be found that the value distribution law of the average index U is as follows. The point date with a small difference between the result dates are subjected to a unified clustering operation, and the nodes greater than 0.5 are clustered separately through the above analysis. The sample library is constructed and the BP neural network is trained. Perform Siemens clustering on the pre-processed data. From the above clustering results, there is a clear gap between the three types of results. At the same time, for the traditional fuzzy Siemens clustering, the data clustering effect processed by the BP neural network is better. Conclusion. In the traditional analysis of user electricity consumption behavior, due to the current large amount of data, to a large extent, the increase in the amount of data will greatly increase the noise points in the clustering results, and the large amount of data will the cumulative effect of errors in the clustering center of the clustering results appears everywhere. Therefore, the BP neural network is introduced to analyze the actual situation of data collection and the current electricity consumption, and the data is processed and classified by the BP neural network. Clustering analysis of the data processed by the neural network can find that the noise points and errors in the clustering are largely reduced, which has obvious improvement effects. Thanks for listening.